Hello there, and welcome back to Hydroponics Daily, your go-to podcast for everything soilless cultivation. I'm your host, Dr. Russell Sharp, the founder of Utrema Limited. Now, when it comes to hydroponics, there are lots of positive environmental claims that can be made. Like if you're using a recirculatory system, the reduction in water use is extremely dramatic compared to conventionally grown crops. And you can make all sorts of claims about carbon footprints of the crops compared to bringing them in from other regions, depending on where you are growing crops and where you're consuming them. But one of the big disadvantages of hydroponic and greenhouse cultivation and indoor cultivation has always been the need to enrich the growing environment with CO2 for optimal conditions. Because normally in a large scale greenhouse, you'll have a gas burner that will triple the amount of CO2 in there. After that, the contaminants in the flue gas will lead to detrimental effects, and it will no longer be economical to increase the CO2 levels beyond 1,000 parts per million. Same in indoor growing. However, in indoor growing, you might use CO2 canisters to remove that need for burning, but people still use burners indoors, but you have to be really careful. So both of them rely on the burning of fossil fuels to triple that CO2 level. And that's been one of the big issues. And it's a real big problem where you have these greenhouses that are in the middle of summer burning CO2 and then having the vents open, which is crazy. So there is a new type of technology, and I am not an expert in it, but it does sound promising that it could potentially lead to CO2 enrichment without the need to burn CO2. And the CO2, the carbon footprint of it is massively low if you're using renewable energies, things like solar or wind or tidal or even nuclear to create the energy to capture the CO2. And it's called DAC, or direct air capture. And I'm not sure how it works, but basically you can capture CO2 from the ambient air, concentrate it, and then put that into your growing environment. And there is a Japanese company that is leading the way, and it's coming to European greenhouses. So it's going to be at Green Tech in 2026, this technology. Seibu Gaiken, BSTAB. That's a really interesting, easy to remember name. Part of the Japanese publicly listed Seibu Gaiken group. They're experts in air treatment, and so potentially these units will be coming to large greenhouses. Obviously not small scale growers to begin with, because these are very large units, but potentially they could be a good thing, because as well as increasing CO2, it could potentially remove volatile organic compounds, modify the humidity, even look at things like temperature as well. So it's been tested in Japan, and the trials have been successful. And they've done trials in 30 crops in the Fukuoka Prefecture. I have no idea where that is. And I've been to Japan, so I'm sorry I can't help you there. And they showed an average increase of 20% in yield compared to when using their system compared to without CO2. Other methods of CO2 enrichment that don't rely on fossil fuels are things like CO2 from breweries, natural sources of CO2, microbial digestion. However, they can contain deleterious gases like ethylene, so you have to be careful. You have to be able to scrub that. So there's a few people working at that sort of side of it. But a really interesting new potential of using this DAC, direct air capture technology. If you are running on fossil fuels, then the footprint can rise to, half a ton of CO2 emitted for every ton of CO2 captured, which sort of erodes the advantage. So clean energy is key for this technology if you really want to talk about its benefits beyond just clean CO2. Now, these units won't be producing anywhere near the same amount of heat as a gas burner. That could be an advantage. So you don't have to waste the heat in the summer. And so it could be really good use, or it could be a disadvantage because you are not getting that heat when you need it in the crop. So you might have to look at other sources of heat, like ground source heat pumps that could be run on renewable energy. But, there's lots of options. You could have electrical heaters if you've got renewable energy and ample sources of it in your area, or you could have both. You could have a gas burner for the winter and the colder times, and then you could have direct air capture DAC systems in the summer. Now, I'm not sure if this technology is really proven, if it's ready to go, or if it's still experimental. I'm sure there are engineers who know more about it than me. So more than happy to be a late adopter of this technology, especially as I don't run large-scale commercial glasshouses. Be interesting to know if vertical farms take up this technology first, or whether it's large-scale greenhouses and, cucumber and tomato growers, or is it indoor growers? Small scale, is it legal cannabis growers? Could potentially use this with a clean source of CO2. Let me know your thoughts. Would really be interested to know if you've got any experience of working with this. Is this old hat? Have I not just never come across it before? And it's widespread. The problem is the units look like a lot of units you get in greenhouse trade shows. So I don't know if it's something completely new or if it's something bog standard. I think the unique technology is inside the big metal box with flue tubes coming in and out. So let me know if you thought this was interesting. If you did think this podcast was interesting, then please do leave an Apple podcast review. If you're not listening to Apple, don't leave a review. Just follow the podcast and then go over to utrema.co.uk, where you'll find a whole range of interesting technologies that you've never come across before. If you've not come to the Utrema website, that's because we have completely unique technology when it comes to fertilizers, biostimulants, and biopesticides. Many of our products can be used in hydroponics because they are premium products, often too high specs for what our customers need. But that's my problem, not yours. Until next time, thank you very much for listening. It's been Hydroponics Daily. Goodbye.